table right now.
About
It's
6
pretty
inches
high.
below the soil.
It's probably still coming up. If you look right there in that pit, and when we walk through the field over there, anybody get their feet wet?
Oh yeah.
Yeah. So we're standing right at the water table, and you can see there's a little drainage way here, and then Cane Run Creek is just right on the other side of that corn. And actually this field here has been tiled. So there's drainage tiles that go under here that semi keep it dry, but apparently not completely. So when we were at the other site, somebody said something about porosity. Okay, so in that A horizon, where do you think you have the A horizon? We had what, a silty loam soil, right? And then down deeper we had a silty clay loam. Which one of those do you think has more pores?
The silty, the one that's not going to have the smaller particles.
Okay. So do you all agree?
Yes. Silty clay loam.
Okay. Silty clay loam.
I think they disagree.
Clay has more micro.
The bigger
So,
particles will have the more
Smaller pore sizes.
Right. So this type of pores are going to differ. So the upper part is going to have more macropores, and where we get into more clay, we're going to have more micropores. So when we look at total porosity, there's actually going to be more pores down in that clay than there are up top. But because there's bigger pores up top, water can move through that quicker, and then it slows down as you get deep. And so why is that important from a plant perspective, that happens that way?
You don't want to waterlog the plants.
So yeah, so you want water to drain so you don't flood them out at the surface. And why might it be important that you have like these micropores holding water deeper down?
During drought? Yeah.
Right, so when it dries up, the plants can actually access that water deeper in the soil profile. So it's sort of a cool thing about these soils. We talked why these are such good agricultural soils, and that relationship of building clay in as you go deeper is sort of a safeguard for, you know, the normal climate that we have here, where it's wet early and then it starts to dry up later in the growing season because the plants have been using all the water. Well, they can still access water deeper in the profile because it's being held in these micropores that are associated with the clays. So that's sort of an important part about the drainage in this system. So we get down here and we're closer to the water table, and so we might have more trouble growing, say, our corn crops and things like that, because we might have inundation and things like that just because our proximity to the water table. So one of the things I just mentioned is they put in drain tiles that take that water out of here to keep the water table a little bit lower, so it doesn't have you know, that sort of issue of waterlogging the plants and killing them. So a lot of the area along the Mississippi River, most of that agriculture has been made by putting big ditches and channelizing areas to access water out of those you know, drain tiles that go to drainage ditches and then go to the rivers and move water out of that system really quick. And every time there's a big flood, people sort of, you know, question about the processes of doing that, where, you know, those were historically wetlands, and they probably would have protected the Mississippi River from flooding by suppressing that water movement, slowing it, you know, as it goes into the river, instead of having, it's kind of like in the city where we have storm sewers and stuff like that move water really quickly. So drain tiles and things like that are very similar to what we have in a city for conveying water out of that system. So right now there's a big movement in the Mississippi River floodplain areas to actually go back and get rid of those drain tiles and fill in those, you know, channels and things like that, and restore the wetlands as a water quality protection and as a, you know, storm water protection measure as well. So what do we see different here than what we saw up there? You can't really see a lot.
Water.
We could build a drainage ditch to drain all the water out. That'd be kind of fun.
It looks darker to me.
Why would you think it would be darker? And it is.
Higher water content. Anybody want to do a color on it? Higher water content. Different.
It could be. So yeah, there's a bunch of reasons
Anybody want to
why.
do color?
But
It's not.
she said higher water
I can do color.
content.
I'll do color.
Can you do color on it?
And so
Do color?
why would higher water content? So yeah.
Yeah,
So
Mikey's got a
you're
color.
keeping it more in a reduced state. That's one thing.
Plenty moist.
So if you have more moisture, what's that slowing down?
You're going from aerobic to anaerobic.
Yeah. And so you're not going to have the oxygen present to oxidize. I don't know, man.
Well, no, you're right. So you're all going in the right. We're not in a wetland type of situation here, but because it is moisture, the microbial activity in the soil might be slowed a little bit. So when that happens, what happens to organic matter?
Builds up.
It builds up or it doesn't decompose as quickly. So you might see a more organically enriched soil here. What's our landscape position?
But we got 10 wire 4-3.
So the trees are where the cane run is at. If that gives you perspective.
Either the. Are we in the old green? What's
Terrace.
Yeah. Toe slope probably, because we're right at the bottom of the hill here. We have a good ways to go before we get into the floodplain. The floodplain here is probably not all that wide. What would you say?
This well, it could be really big in this valley type just because that's the way it is. In some valleys you'll get much smaller with them. So when Amanda talked about the terraces and she drew it on the board, it was pretty defined. Some systems like this, you may not have these really big defined, big terraces. Like you can go to Robinson Forest and you can actually see some good sized terraces here. It'd be it's harder to see where some of them may have been.
Yeah. So in a toe slope position, do you think we have residuum as our parent material like we had up top? What would it be?
I heard it.
Colluvium.
Yeah. Nice, Owen. So not like you might have in a mountainous area where you have big rocks and stuff moving down the hill and soil forming from that, but you definitely over the last, thousands of years have had soil moving down. These soils have been eroding down into this landscape position. So we would have a soil formed in colluvium. So it might be a bit different than what we have up there. We might have a very deeper, richer A horizon because of all of these processes we've talked about, but the soil might not be as deep.
As we get, I was just going to say, as we get even lower in the landscape, you can see that horizonation. You might even see something that we call a buried A horizon. So that dark material that used to be at the summit, making its way down and depositing in that, maybe in a toe slope area too. And you'll see, it's a dark color on top maybe because of the organic matter, but then it may
get really dark below it.
Yeah.
And
like
you actually
extremely
have
dark.
that in this bottom in areas. You'll find a band of like really dark soil that's above a soil that is lighter than that. And that's a buried horizon from a long time ago. And we see those around Fayette County and central Kentucky in not landfills, talk about in sinkholes. And so lots of times if you dig a soil pit on the side of a sinkhole, you can see soil development, and then you'll see this dark band, and it looks like charcoal in some cases, and then another soil formed below it. And so that was an area that filled up, or when the sinkhole dropped, a new soil created on it. And so that's not all that common, but you do find that here in sort of the central Kentucky region.
So I want you to think about one thing, and I think about this because I do a lot with what we call low impact development or green infrastructure stuff. But I want you to think about this next time you go places by Masterson Station and think about it how when Chris was talking up here and Amanda were showing us the different layers, and we're talking at the top about being a bit more infiltration. So when I go in and build a neighborhood, how do they do it? I mean, what's one of the first things they do? Huh?
Grade
They
it.
grade it out. Okay, so what do they do with that? So they grade that part of the soil. What part are they grading away?
The topsoil.
The topsoil, which is good for what? besides having organic matter, what were they on the water part of it? What was it good for? Drainage. And then then we hit what? We hit soils that don't let the water through as well, right? So not only when they build those areas, they're not always going to say this is exactly where I'm going to put that house or that building, and I'm only going to do something there. They take a big area and they run through and do that. So now I've taken off the soils that drain better, but I've also put on top of it what? What are they using to do that with? What are they using to move the soil?
A big machine.
Big machines, right. They start doing compaction. So not only do I have soils that don't infiltrate great to begin with, I actually compact them more. So when we think about development, and we really fixate a lot of times on, oh, this is impervious area or impervious, it won't let water through, we have to also think about that pervious area and how we've changed that so it doesn't actually let water go through as well anymore. So when we think about doing that, I think to me that's a big point too. And a lot of times when we as engineers look at soil, and we use this a lot when we try to look at hydrology of how water is going to move through an area, we have to also think about, oh, well, at the top it might be this soil type, but really what we're dealing with once we develop is what's underneath it. Yeah.
Yeah.
Any questions or observations that you want to share, or quandaries?
I like how this connects so many different disciplines. I like how it connects the geology and some of the ecoregion stuff and the biology and the land management parts of it.
It's pretty much the most important thing.
Yeah, it really is.
What kind of
No bias.
And we've got, water we can talk about too in the pit. I think I made a perfect boot washing station.
Well, there's a great hand washing station over there.
I'm gonna go to use it.
All right, so
oh wait, you have a question?
The
Yes,
water,
please.
how high do you expect it to come up? I mean,
Well, I imagine it'll come close to the surface just based upon that. So when I got here at 9 o'clock and dug this, and what is it, 10 o'clock now? And it's gone up, 8 inches?
yeah.
So it's still, it's just perking up.
So how far do you think you're to bedrock there, Chris?
2.5 feet probably. I don't know.
Oh, I'd say deeper than that.
How deep was that pit?
I don't know. It's been so much water.
Well, the reason I asked
someone
you,
jump in.
I know, like,
Every
when
time I've been to
gone
that
on
Wolfer
King
pit,
Run,
it's
sometimes
full of
if
water,
we're
too.
really close to the stream edge, it might be less than a foot we're hitting bedrock, but as we get a little further away, it gets a little deeper. But
Yeah,
I
know
think
that
it's a little deeper.
there was a pit over there that was only about 2 feet deep. And that one we hit bedrock at about 6 feet. So probably somewhere in the middle of there.
right.
Three,
And that's
3.5
important
feet.
too, like for water to infiltrate. One is it hits other water, it's got no place to go, but if it's also hitting bedrock, that's going to be.
But also, as we get closer to the stream, we may have those more sandy textures that have been dropped out as alluvial material.
And there's a lot of gravel
So,
you can feel.
yeah, there's a lot of
on the-
gravel.
when you dig around there.
Yep, absolutely. Is anybody anybody worked on the homework other than Eric?
I opened it.
I thought about it.
Did you have any trouble importing the files?
could use a Chromebook so it doesn't do any of that.
Okay, so there's PCs in the library, the Ag North Library that you can go check out or the labs or something. If you have trouble importing those files in for that part of the homework, let me know. It worked on my computer, but we'll see. Eric thinks maybe his computer is aged. Aged. But there's two different parts. At least I know you can do the first part or one of the parts where you're just defining an area. So go on and do that and practice and let me know if you have trouble with
And
that.
don't wait till the last minute, okay?
Yeah, because you'll get frustrated.
Okay.
Because web soil survey is like any other web application. It's trial and error to some degree, and you may go down a rabbit hole. And oh, look at this, and then maybe they won't. Maybe
Nobody.
some hours go by.
Nobody does that.
Hours go by, and you're like, well, wait a minute, what was I doing? Anyway, but let me know.
All right, well, let's thank Amanda and Chris for our awesome time here. And then gather up the tools that we need to help take back for you all.
I just need to go get my Tupperware.
And then we'll clean
Just
up
make some of my
somewhat
Tupperware.
and hop in the van. Oh, Victor.
And if you have a trowel, those go back in Chris's